Okay, this is a continuation of the practice test for MAC 1140 Pre-Calculus. We're talking about the topics on exam number 3, which cover sections 11.1 through 11.6. We've moved on in this video to problems 29 through 38, which are the problems from section 11.3. Okay, so on problem number 29, you go into finding the value of a determinant. So let me remind you of that formula. You're doing the downward product first. So that's going to be 12 times 3, and you can just write 36. I'm just showing it to remind you. Minus the upward product. Do the downward product first, then you can subtract the upward product. You have to do it in that order. Upward product here would be positive 28. I'm just going to show you once, but then I'll just jump into the numbers from now on. So this would be 36, and this would be fine for you to show me minus 28, which is equal to 8, and that is choice D. Okay, moving to number 30. Once again, in number 30, you're using the concept of finding the value of a determinant, which is what these, I know these look like absolute value bars, but when you're talking matrices, it stands for finding the value of a determinant. So you have the determinant 5, 9, negative 2x, and since that determinant includes a variable, you will be able to solve for x using the concept of the determinant value. So it says the determinant value is equal to 8. That's going to allow us to get an equation. So calculating that determinant value, it's the downward product first, 5 times x, minus the upward product, which is negative 18. So this represents the value of the determinant, and that value is equal to 8. So this is 5x plus 18 equal to 8. Bring that 18 to the other side and it becomes negative 18. And then you end up with 5x equal to negative 10. Dividing both sides by 5, you end up with x is equal to negative 2. Okay, so B. Number 31, moving on to Cramer's rule. Cramer's rule also involves determinants. There is the main determinant, which is made up of the coefficients of the variables. So this is called the coefficient matrix. And you're going to be finding the determinant of that coefficient matrix. So that would look like this. You just use the coefficients for x in the first column, coefficients for y in the second column, and this determinant value is actually going to play the role of the denominator each time you set up a fraction that will allow you to solve for x and y. So this is not the quickest way to solve a system, but it is taught in this section, and I expect you to show these determinants by hand at least once in the test. So the value of this determinant would be 2 times negative 2, which is negative 4, minus 3 times 2, the upward product, which is 6. So that becomes negative 10. And we're going to use that in our denominator when we find x and y. The next determinant you're going to find is d sub x. And what that means is you're going to set up your determinant, but you're going to replace the x coefficients with the 26 and the 14. So 26 and 14 will replace those x coefficients. Leave the y coefficients as is, positive 2, negative 2. And go ahead and find that determinant because we're going to need that too in order to find x. So 26 times negative 2 is negative 52 minus the upward product. And that would be negative 80 when you combine those two. Okay, in order to actually find x from this, you would go x is equal to, and the formula for finding x by way of Cramer's rule would be the d sub x determinant value over the main determinant value. That would be negative 80 over the negative 10 that we found, which is 8. So that's the value of x. Okay, when we go to find the y value, we need to find the d sub y determinant first, and that is just the determinant of values where the y coefficients, the 2 and the negative 2, are replaced by the 26 and the 14, where the x coefficients remain the same. Okay, so when finding the d sub x determinant value, replace the x's with the numbers on the right side of the equal sign. And when you're finding the d sub y determinant value, replace the y's with the 26 and the 14. So this determinant value would be downward product first, which is 28, minus the upward product, which is 3 times 26. You can pop that in your calculator. It's 78. 28 minus 78 is negative 50. If you're going to find y using this d sub y determinant value, that formula would be the d sub y determinant value over the main determinant value. So that would be the negative 50 that we just found, divided by the main determinant value, which was negative 10. And that would be equal to 5. So we got 8 for x and 5 for y. So the system solution, the solution for this entire system, you know you have to give the solution for x and y as an ordered pair. So x is 8 and y is 5. I mean, not that I wouldn't give you credit if you just state what x and y is. Okay, this was our x value, this was our y value. So up here, that would be choice B, it looks like, for number 31. Okay, moving on to 32. Okay, in problem 32, this probably goes with the same, if there's not a new set of instructions, then that just means that you are using the last bit of instructions from the previous page. So we're using Cramer's rule to do number 31, 32, and it looks like 33 as well. Because once you get to 34, it's a new set of instructions and a new size determinant. Okay, so let's practice here. See how much of it I can get on this actual paper. If I can't fit it here, I'll move to another sheet. Okay, so let's do the main determinant value first. That's just the determinant of the coefficient matrix, so 816. And then negative 2, negative 4. And I'll just do each determinant as I go along. 8 times negative 4 is negative 32. Minus the upward product, and 16 times negative 2 is negative 32. Okay, so this ends up being negative 32 plus 32. Okay, which ends up being the main determinant value ends up being 0. Okay, so let's think about this. For problem number 32, think about how we would eventually be attempting to find x. We would go, if we wanted to find x, which I'm not going to bother to find these things because I think you can see that it is impossible to go further with this problem. Because if you were going to find x, you would find d sub x, but then don't both of these, whether you're finding x or y, don't they both get divided by the main determinant value? And what that makes this undefined. So you cannot go on with this. The same thing would be true if you went to go find y. It would be the d sub y value, which why bother finding that if your denominator is going to be a 0, because this would be undefined also. So by Cramer's rule does not apply to this particular system. Doesn't mean that there's not a solution, because when the d value is 0 in Cramer's rule, that can mean one of two things actually. It can mean that the system is either inconsistent and doesn't have a solution at all, but it can also mean that it has infinitely many solutions. But with respect to the way this question is asked, they wanted you to use Cramer's rule, and if it wasn't applicable, which this tells you right here that it is not applicable because it makes the rest of the Cramer's procedure undefined. Okay, and number 33, we're going to do the same thing. We're going to find the main determinant value, which in this case would be, let's go grab the coefficients of the variables x and y. So coefficient of this x is 1. Coefficient of this x is 0.5, or you can put a 1/2 there if you want. Coefficient of the y's, 4 and -1. So when we go to do the downward product, and you can put these determinants in your calculator, but it doesn't make sense to do that when it's a 2x2, because it's quicker to just do it by hand. So downward product, -1 minus the upward product. 0.5 times 4 is like half of 4, which is 2. So this turns out to be -3. So we're going to be using that for our denominator. Okay, then in order to go on with the problem, we also need d sub x, and that's where we created a determinant where the x coefficients are replaced by these numbers on the right side of the equal sign of the equation. So the 28 and the -6. The 28 and the -6 replace the x coefficients, while the y coefficients remain intact, 4 and -1. And we go ahead and we find that value. So 28 times -1, always do that downward product first. That would be -28 minus -24, which is really -28 plus 24, which is equal to -4. Okay, so we'll be using that as we go to find x, because x, according to Cramer's rule, is the d sub x determinant value divided by the main determinant value. So that d sub x determinant value is -4. And the main determinant value is -3. Okay, so this is going to be 4/3 for x. Okay, and then moving on to find y. Let me see what number. Let me turn the lights on. Hold on for 1 second. Some light going on in here so I can see what I'm reading. Okay, so we are on problem 33. Okay, so, I mean, you can already tell which one of these is the answer, assuming that you did everything right, but I want you to practice doing the whole problem for each and every problem on this practice test, because most of your problems will not be multiple choice. You need to show how you got each and every answer. So we have the answer for x. If we were going to find the answer for y, we would just continue by setting up the d sub y determinant value. And that just means that we're going to be taking the y coefficients, the 4 and the -1, and replacing them with the 28 and the -6, while leaving the x coefficients just as they are. You can write it as 1 and 0.5, or you can write it as a 1/2, that 0.5. In any event, it's 1 times -6, -6, minus half of 0.5 times 28 means half of 28, which is 14. So you got a -6 minus 14. -6 combined with -14 is -20. And then when you're going in for the y value using Cramer's rule, it's your d sub y determinant value over your main determinant value. So that would be -20 divided by the main determinant value, which was this -3 that we found at the very beginning. That always plays the role of the denominator, leaving you with 20 over 3 for your final answer for y. Okay, and that would be choice D. Okay, so we had a few problems where we were practicing the use of Cramer's rule in order to find the solutions to a system. Okay, now we move on to the use of a 3x3 determinant value. And when you're finding the determinant value for a 3x3, what happens in those particular problems, now I'm going to do this by hand, and I'm also going to do it by calculator. I want you to, if there's, a couple of problems, I want you to show me that you can expand it by hand, just so, you make sure that you are able to do that in case that's all that will be allowed when you get into the next course. So what happens with the 3x3s, if you're going to do it by hand, is that you're going to take the first two columns, the 646 and the 224, and you're going to copy it on the outside of the determinant symbols. Okay, so just 6, 4, 6, and 224. And what you're going to do in this case is you're going to do 3 rows of downward products. So let me demonstrate that. And you have to be able to draw these lines nice and straight. You're going to do the downward product for that row. You're going to do the downward product for this row right here, and you're going to do the downward product for this row. And I'm going to go ahead and write those numbers at the end of each of these little arrows. Okay, so the product along this arrow would be 6 times 2 times 1. 12. The product of the numbers along this line right here would be 2 times 5 is 10. 10 times 6 is 60. And of course, you can use your calculator for that. Okay, and then the downward product along this arrow that I've drawn is 1 times 4 is 4. 4 times 4 is 16. So these represent your downward products. You're going to collect them all together. 12 plus 60 plus 16. Okay, these were your downward products, but you have to add them all together. So it's still going to be downward product minus upward products. And your upward products, what you're doing is drawing some upward arrows. This would be the first one. This would be the next line of numbers. And this would be the last line of numbers right here. And that's why you need these extra 2 columns so that you have 3 numbers in a row to multiply. So doing this one upward product, 6 times 2 times 1 is 12. And then 4 times 5 is 20. 20 times 6 is 120. And then this last string of numbers gives you a product of 1 times 4 is 4, 4 times 2 is 8. So all of your upward products are 12 plus 120 plus 8. Okay, so when I put all these together, you get 88 minus 12 plus 20 plus 8, 12 plus 120 plus 8. And that's 140. Okay, let me check these out again real quick. First product going down was 12. Second product going down was 60. Third product going down was 16. When we added those up, we got, let's see, that should have been 88. That is 88. And then my upward products were 12. 4 times 5 was 20. 20 times 6 was 120, so that's correct. And then 1 times 4 is 4. 4 times 2 is 8. So finally, when you go 88 minus 140, you get negative 52. Now we can also check this answer by doing a determinant in the calculator. Luckily for us, that answer is available. But as one of the multiple choices, is it the correct answer? Well, obviously we have an answer key for this one, but on a test you are not going to have an answer key. So here is a way to, use your calculator as an answer key. So if you were going to do this in the calculator, you would just be feeding in the numbers, not these expanded columns. That's when you're doing it by hand. So you go second matrix over to edit. Press that, and then tell it what size matrix you're going to put in there. So this is 3 rows. You always talk about the rows first, then the columns. So this is 3 rows, 3 columns. When you're doing determinant, it's a square matrix anyway. So 3 by 3, then press enter, and it'll open up a matrix in there. Fill in the numbers. So you're filling in the numbers going across. 6, 2, 1. Just put 6, enter, 2, enter, 1, enter. You hop down to the second row where you're putting in 4, then 2, then 5. 4, enter, 2, enter, 5, enter. And then you're coming to this last row, which is 6, 4, 1. 6, enter, 4, enter, 1, enter. Okay, now as soon as you're done putting in all the numbers, quit out of this matrix screen. Second, quit. And now you're going to do matrix mathematics, which one type of matrix mathematics is finding the determinant. So you're going to go second matrix over to math. Go grab that very first option, which says you're going to be doing the determinant of a specific matrix. Now you need to call up the name of the matrix. So where we just put the numbers in was the very first matrix, which is called matrix A. So second matrix. Call up matrix A, that 3 by 3 matrix where we, it was already on there. That 3 by 3 matrix where we just put the numbers in. Okay, close the parenthesis, and there you go. You have used your calculator as a way to check the answer that you just did by hand. But anyway, that is expanding it and doing it by hand, and then I also demonstrated in the calculator. Sorry about that. Okay, then for number 35, we have the same thing going on, only this time you're going to have to do it by hand because there's a variable involved there. So that's why I demonstrated this, because for some of these problems you can't just toss it into the calculator. If all they do is ask you to find the value, then you could put it in the calculator, but something like this, which is what I'm more inclined to put on the test, would require that you do it by hand. So if you're going to do this by hand. Remember that to do the value of this determinant, you're going to have to expand it using these two columns. So in that particular case, it would be x, that 10 is in the way, otherwise I would do it right there. -2, -1. Make these nice and straight because you need to line them up. So 4, 2, -2, -1, 0, 8. Now expand with the first two columns. X, -2, -1, X, -2, -1. Same way you would do it if these were just all numbers, like in the previous problem. -4, 2, and -2. Let's find the determinant value of this first, which is what I'm doing right here, and then we'll set it equal to 10. Okay, so using those arrows that I showed you, you're going to do downward product right here, downward product right here, downward product right here. Okay, let's do those downward products first. So this would be, let's see, 8 times 2 is 16, 16 times x, 16x. Then multiplying here, we would have -4 times 0 times -1, 0. Then here we would have -1 times -2 is 2. 2 times -2, -4. So my downward products all combined would be 16x plus 0 plus -4. This represents 16x plus -4 because of course you don't have to put the 0 in there. Okay, those are my downward products. My combined downward products minus your upward products. So draw the arrows going up, up. Here's another string that we're going to multiply. Here's the last string that we're going to multiply. Okay, so as you do this upward product, it's -1 times 2 is -2. -2 times -1 is +2. This next upward string of numbers forming the product here would be -2 times 0 times x, 0. Then right here, if you do this upward product, it would be 8 times -2 is -16. -16 times -4 is 64. Okay, so let's combine all of our upward products. Okay, so my upward products are 2 plus 0 plus 64. I'm not going to throw the 0 in there. Okay, so this would be equal to, this combines into, let me just put it right here. Remember, all of this represents the value of this determinant. That's what we're working on. That value is equal to 10 because we do want to allow our equation to evolve here. Okay, so if we combine these terms right here, we have 16x minus 4 minus 2, and then minus 64. Okay, this gets entered as a -2, this gets entered as a -64. So -4 combined with -2 combined with -64. And that's -70. Is equal to 10. Okay, moving the -70 over to the other side makes it a +70. So that's no longer there. And we have 16x is equal to, got to do it down here, 80. And then divide by 16, divide by 16, and we end up with x equal to 5. Okay, let's see if that is an answer. We have this choice right here for C for 35, and that is correct. Okay, moving to the bigger system. So here I'm allowing you to move to your calculator completely. You still have to set up the determinants, but then you can pop them into the calculator instead of doing all these arrows 3 times in a row. Okay, so 36 and 37 is our opportunity to practice for this extended type of system. And I'm going to move over to paper because I'm going to need it. Okay, so for this first problem, let's go ahead and set up all our determinants. Okay, so one of them is going to be 3, 1, -3, 2, 6, 1, 2, 6, 1 on the y's, and the z's are -1, -2, and 1. -1, -2, and +1. Okay, that'll be our main determinant value. Main determinant value, and we will pop that into the calculator. So let's just go ahead and set up all the determinants. We need one for d sub x, d sub y, d sub z, because now we've moved to 3 variables. So d sub x just means that you're replacing the x column. These are the coefficients for x. These are the coefficients for y. These are the coefficients for z. I'll just label them up here so you can keep your head on straight about what's going on. And now here I am creating the d sub x determinant. So I'm going to replace this, this, and this with the 30, the 28, and the -18. While keeping all of the y coefficients and the z coefficients the same. So 2, 6, 1, and then -1, -2, +1. Okay, then my d sub y determinant value is going to be replacing all the y values with the 30, the 28, and the -18. So now coming in here and replacing 2, 6, and 1 with 30, 28, and -18. While keeping the x coefficients the same. Get back in your place. Okay, then my y coefficients were -1, -2. You gotta be so careful writing these because it's lots of places to make mistakes. 3, 1, -3. 30, 28, -18 replaced the 2, 6, and 1. Copied -1, -2, and 1. Okay, then my d sub z determinant would be replace the z coefficients with the 30, the 28, and the -18. And then the x and the y column would remain the same. So 3, 1, -3, and then 2, 6, 1. Okay, so we need all of these values in order to be able to solve for x, y, and z. Okay, so I'm going to go and put this in the calculator. I'm going to put all of these in the calculator. I'm just going to put these values down here so I have room. This one I'll put right here. This value, I'll try to put it down here, and I'll try to circle them each time I do them. Okay, so the job of putting this in the calculator. Okay, so main determinant value. Okay, let's go over the moves of actually putting this in the calculator. You go second matrix. Editing is what allows you to fill up a matrix of any size you want. Ours is 3 rows, 3 columns. So edit, make sure it's the right size. It is. Jump down into the matrix and start filling in the numbers from your matrix. You're filling the numbers going across. So 3, enter 2, enter, -1, enter. Check that real quick. Then 1, 6, -2, 1, 6, -2. Check those real quick. 1, 6, -2. And then -3 for that bottom row. 1, 1. Okay, now quit out of here. Second matrix again. This time we're going to do a specific type of mathematics on this matrix called the determinant. So it's already on option 1, the determinant. Otherwise you could pick from these options down here. And we're doing it to matrix A. That's where we just put all the numbers. So call up matrix A by going second matrix again. You do everything under second matrix and then it'll be in the menu. Okay, we're using matrix A. We're doing the determinant. That value turned out to be 15. We're going to need this in order to find X, Y, and Z. So that's the main determinant value from the coefficient matrix. Then D sub X. Okay, what I'll do now is I'll clear this out. I'll go into second matrix. I'm going to go over here to edit again. It knows it's a 3 by 3. Just jump down into the matrix, start filling out the numbers. For D sub X, it's 30, enter, 2, enter, -1, enter. Going across the second row, it's 28, enter, 6, enter, -2, enter. Then going across the bottom row, it's -18, enter, 1, enter, 1, enter. We check these numbers real quick. 32, -1, 28, 6, -2, -18, 1, 1. Okay, quit out of there. Second quit. Now we're going to go to second matrix and we're going to do the math called finding a determinant. Choose that. Call up the matrix you want to find the determinant of, which is matrix A. So go second matrix, choose matrix A, close that up, get the determinant value. That turns out to be 120. So we'll be using that when we go and find the X value. This D sub Y value, I'll put it down here. Again, go to second matrix, edit to fill in the new numbers for your new 3 by 3. This one goes, whoops, jump down into the matrix with this downward arrow, start filling out the numbers. 3, 30, -1. So 3, enter, 30, enter, and -1's already there. Okay, come down into the next row. Oops. Okay, so then the next row of numbers, I got a 3, a 30, and a -1. In the second row, it's 1, 28, -2. 1, enter, 28, enter, and -2 is already there. Okay, so now I'm down in the third row. So it's -3, enter, -18, enter, 1, enter. Okay, check these numbers out. 3, 30, -1, 128, -2, and -3, -18, 1. Quit out of there. Second quit. Now we're going to go to second matrix, over to math, choose the formula for determinant, the operation. Tell it what matrix you want to do it to, which is A, and you get a 60. Okay, moving on to D sub Z, that determinant value. Okay, so one more of these, getting closer. I'll put it over here so you can see it. So second matrix, over to edit, 3 by 3, start filling in these values for the d sub z determinant. Okay, so jump down into the matrix, you got 3, enter, 2, enter, 30, enter. You're down in the second row now, where it's 1, enter, 6, enter, 28, enter, and then -3, enter, 1, enter, -18, enter. Quit out of there. Then it's second matrix. Choose the type of mathematics you want to do the matrix, which is finding a determinant. Call it matrix A. That value turned out to be 30. So you have all the values that you need for 36 now. And now you can go and find x, y, and z. X is the d sub x determinant value over the main determinant value. So d sub x is 120. 120 divided by the main determinant value, this was 15. Let's see what kind of answers we got here. So 120 divided by 15 is 8. So we have 8 for x, and then y is equal to d sub y divided by the main determinant value. Our d sub y value is 60. Our main determinant value is 15. So this goes in here 4 times. 60 divided by 15 is 4. Okay, then we have to still find z, and that would be the d sub z determinant value divided by the main determinant value. So d sub z is 30, main determinant value is 15, and this turns out to be 2. Okay, because you're in a system where there are 3 variables, you're going to give your answer as a triple ordered pair, where you're listing x first, then y, then z, always in alphabetical order when you're giving these ordered pairs. So 8, then 4, then 2. Okay, let's see if there's an answer like that. Hopefully there is, and that would be B for number 36. And that is correct. Okay, moving to 37. Okay, so solve the system using Cramer's rule. If it's applicable, if it's not applicable, say so. So if one of the choices is that, then it's not. It's probably not applicable for this one. So we'll just check it out. The main determinant value in this particular problem would be 1 to -1. Because if the main determinant value is 0, which plays the role of the denominator each time, you can't go on with the problem because Cramer's rule is not applicable. So let's see what happens with this main determinant value. So it's 1, 2, -1. Those are the coefficients of x. For y, it's -1, 0, +1. -1, 0, +1. And for the z coefficients, it's 4, 1, -4. 4, 1, -4. I mean, you should probably always find the d value first because you might not have to go on with the problem. So let's see what happens here. Rather than setting up d sub x, d sub y, and d sub z, I guess this would be the smart way to go. Just figure out whether even d is going to work. So let's clear this out. We're going to go to second matrix, over to edit once again. Let's see, it's 3 by 3. Jump into the matrix. First row is 1, enter, -1, enter, 4, enter. Okay, 1, -1, 4. Then it's 2, enter, 0, enter, 1, enter. Last row, -1, enter, 1, enter, -4. Oops. -1. Supposed to be 4. So I got -4. Okay, so 1, -1, 4, 2, 0, 1, and -1, 1, -4. Okay, quit out of there. I'm going to go second matrix, over to math, choose determinant, and tell it what matrix to do it to. Okay, so because this is 0, that means d sub x, if you were going to set it up, divided by d would be d sub x divided by 0, undefined, as would all the rest of them. D sub y over 0 would be undefined. D sub z over the main determinant value of 0 would be undefined. Okay, so Cramer's rule in this particular problem, because the main determinant value is 0, Cramer's rule is non-applicable. And let's see, that would be choice C, number 37. Okay, moving on to the last problem from section 11.3. And then we'll be doing 39 through 48 in the next video. So here's problem number 38, which talks about the area of a triangle. And the area of a triangle formula, they're telling you it's 1/2 times all of the values that are occur at the vertices of the triangle. Like each vertex is represented by a point. And these are the points right here. This represents one corner of the triangle. This represents another corner. This represents another corner. So you're putting all the x coordinates here, all the y coordinates here, and all ones. And this is a way to find the area of a triangle if you actually know the x and y coordinate at each vertex. Because you know, if you plot 3 points and then you draw lines between each of the 3 points, you have a triangle. And any triangle has a rectangle, and this is the way to find the area using determinant. So first let's set up our, and this plus or minus, I mean, in the software that I'm using to make this practice test, they write the plus or minus, but really what you're doing, and they explain that down here, is you're taking the absolute value of whatever you get from this determinant value. Take the absolute value so that the area is always positive, and that's why they make this comment here, where the symbol plus or minus indicates that the appropriate sign should be chosen to yield a positive area. That's the same thing as saying take the absolute value of whatever you get from this determinant value and then cut it in half. Okay, so first let's set up our determinant for this particular problem. Just give me 1 second. Okay. Okay, so we're putting all our x coordinates here. So this is x1, x2, x3. So 5, 8, -2. And I'll label these. Try to get a pencil that writes a little better. And this will be y1, y2, y3 as we try to build on this determinant. So 5, 8, -2. 5, 8, -2 for my x1, x2, and x3. And then for y1, y2, and y3, it's 7, -8, -5. 7, -8, -5. And then you put all ones in the last column. Then you're going to go to your calculator in order to figure out this determinant value. So it'll be 1/2, do this in your calculator, calculate the determinant value, and then we will cut it in 1/2. Cut it in half. Okay, so we're going to go second matrix. Oops, I've turned it on. Clear, second matrix. We're still working on a 3x3 here. 3 rows, 3 columns. Oops, guess I need to be able to see the numbers. So go over to edit to tell it you're about to fill up this matrix up with the numbers. Use this downward arrow until you're inside the matrix. Start filling out the numbers. Going across the first row, it's 5, 7, 1. 5, enter, 7, enter, 1, enter. Now you're in the second row, it's 8, -8, 1. 8, -8, and 1. 8, -8, 1. And then that last row is -2, -5, and 1. Okay, now quit out of here. And then go second matrix over to mathematics. You're doing a determinant and you're doing it to matrix A. And that is -141. But again, the comment is that the plus or minus indicates, and even if you didn't have that value, you are to do the determinant value but take its absolute value because area can't be negative. Okay, which means get rid of the negative if it does come out negative. Okay, you're going to take the absolute value. And maybe circle this in the directions. It has to be a positive area. So 141 divided by 2 is 70.5. You can write it like this as a fraction. It looks like this as a decimal. You could give either one on a test. The only time I do not want you giving a decimal is when writing it as a decimal causes you to chop off part of the numbers, truncate the numbers that may run on after the decimal. You don't want to do that so that you can give an exact answer. Now here they give it in fraction form. So 38. The answer is C. So that concludes all the problems from section 11.3, and I will move on to 11.4 in the next video.